Thank you, everybody. Like Michael said, I work with Sherwin on the protective and marine side of the company, and I deal with engineers and owners to help develop coating specifications for high performance coatings and industrial environments and things like that. Brett is my counterpart that does pretty much the same thing on the architectural side. So, see if I can figure this thing out. Okay. So what we're here today to talk about is the surface prep requirements and then some coating options for concrete tilt walls. If anybody has any questions, feel free to stop. If there's time at the end, we can definitely answer any questions you have also. So we're going to talk a little bit about why we should coat concrete, and then also why does concrete need to be prepared before it's coated, and then some of the actual surface prep standards that we recommend written into a specification that if there's going to be coatings on there, and then some of the other characteristics and design things that need to be looked at and addressed before surface prep and coating occur. And then Brett's going to talk about some of the different coating options that we have for concrete tilt walls. So the gentleman before me talked about exposed concrete, and that's very popular, but there are situations where concrete needs to have coatings, whether it's biogenic, microbial, induced corrosion, that we see that a lot of that in industrial environments, whether it's in the oil and gas industry or water, wastewater, where you have high levels of H2S, which react the bacteria in the system, consume that and generate sulfuric acid, which will degrade the concrete and erode it very quickly. Also, things in different environments where we have process or treatment chemicals that can erode the concrete as well. Coatings can protect that. Chloride-induced corrosion from salts, whether you're on the coast or in an environment where we have salts on the roads in colder environments. Also, accelerated concrete carbonation. As carbonic acid, the carbon dioxide in the air, penetrates the concrete, it lowers the pH. And as the pH lowers, the concrete will degrade, causing more failure. And then just things like abrasive and corrosive cavitation, if you have a lot of running water, things like that can actually erode the concrete. All these can cause premature fatigue and can actually lower the surface life of the concrete structure, but if there are coatings applied that can protect that and extend that surface life. So why do we want to talk about the surface preparation before actually applying these coatings? The main thing is to improve the bond. If there's the surface is not prepared correctly, the coating will not adhere correctly, and then again the surface life will be severely reduced. Also, contamination. We'll talk a little bit about the contamination that can be on concrete that could inhibit the adhesion of coatings. And then we want to talk about removing the latents, or the paste layer, which is the very thin film at the top of the concrete that has very little tensile strength that can also affect the adhesion. And then a rule of thumb that we have is the severity of the environment dictates the level of surface prep needed. The more robust coating, the thicker the film of the coating applied to the concrete will require more extensive surface preparation, more surface profile, and we'll talk about that a little bit more in just a moment. So the surface prep standard that we recommend, if you're specifying a coating for concrete, and if you actually add in a surface prep standard, that gives the applicator, whoever's doing the surface prep, an actual standard to follow to get to a quantifiable result before the coating is applied. SSPC SP13 May 6 is the concrete surface prep standard that has been laid out, but we also include a concrete surface profile from the ICRA, the International Concrete Repair Institute, to give a visual comparator so you can actually give a visual confirmation that the surface prep has been reached according to the specification. So the method of prep should always be determined by the applicator in the situation. The standards lay out different methods to get there, and then the different process to get there, can be dictated by where the location. If it's an interior space or an occupied space where abrasive blasting may not be ideal, then high pressure water blasting or something to that effect. And the standard lays out each one of those. And then also, we definitely recommend you consult the manufacturer of the actual coating to be applied to see what their recommendation is for that specific coating in that situation. And then we always recommend doing a pH test to make sure that the concrete is suitable for coating, because as the acid attack, whether it's environmental carbon dioxide or in a situation where you have acid contamination, will lower the pH to the point if you coat over it, that deterioration will continue to happen after the coating. So SSPC SP13 also is a joint standard between SSPC and NACE, which are now a combined entity called AMP. But it lays out all the different methods for preparing concrete, from cleaning, chemical etching, mechanical preparation, which would be abrasive blasting, power tool grinding, impact tools, all of that. But it does not give a very quantifiable, verifiable surface profile to aim for, to get to. It's very vague. So we recommend adding in the ICRI 310.2R standard concrete surface profile, and this provides a visual comparator. These here are rubber reproductions of different surface profiles. So you can specify an SSPC SP13 with an ICRI 210.3R concrete surface profile of 3 to 5. And then that gives you, this is a concrete surface profile 3, and this is a 5. So if you're specifying a range from 3 to 5, and then when the surface prep is completed, the inspector or whoever wants to verify that, they can actually take these rubber coupons and compare it to the surface to verify that the actual surface prep meets what is specified or what is recommended by the manufacturer. So this is just a general guide, talk about the different coatings. Like I said earlier, the severity of the environment will dictate the degree of surface prep necessary. So if we put too much surface profile based on the thickness of the coating applied, there can also be problems there too. So as you can see on thin film sealers, I don't know if that works there, see a CSP 1 to 2 is a very, very thin, low profile. It's removed the latents, it's got us to a good sound surface, but it's not a really aggressive profile, which is what we want when we're talking about thin coatings. You don't want to have a very aggressive profile and then have a thin coating that doesn't cover that profile, because now you actually cause more problems. But as we go all the way down, if we're doing up to a 1/4 inch overlays where you have a very severe environment with a very robust coating with a very thick, heavy system on there, then we can go all the way up to a CSP 10, which if we look here is not something you'd want to walk on barefooted, because it's a very aggressive profile and it's got a whole lot of anchor profile for that coating to adhere to. Okay. So just some considerations about when we're talking about cast in place or put in place concrete, some of the things that we need to be addressed before coating. Normally any poured in place concrete is going to have latents on the surface, and that's the layer of unreacted cement paste that has a very low tensile strength, and it has very poor adhesion, and if you put a coating on there, it can actually cause failure down the road. And then we're also going to have bug holes that need to be addressed, fins and protrusions, form release agents, and then also the pH has to be addressed. So, latents. This is an example of where a coating was applied over latents that was not removed. And as you can see, the coating adhered perfectly. It's just the latents came loose. So that would, as much as that looks like a coating failure, that's actually a surface prep failure, because the latents was not removed. The coating sticks to the latents, which has a very low tensile strength, and it comes loose from the surface, and then we have a problem there. So that has to be removed, whether it's by grinding, blasting, water jetting, or even a chemical removal like acid etching, depending on the situation and what is practical in that on that project. So then we also want to talk about bug holes. And bug holes are just like they're air bubbles that don't quite make it to the surface. So you have a void in the concrete, and you really can't coat into that bug hole. So you have a discontinuous coating film there. So we're in a very corrosive environment, and we have basically incontinuity there of the discontinuity of the coating film. That's a coating. That's a failure point. That's where the concrete can still be attacked by the environment or the commodity that's there. So these need to be opened up, whether by abrasive blasting, water jetting, a ball peen hammer, something that can open these bug holes up, get them completely open, and then filled with the correct surface depending on the coating system that will be applied. And then fins and protrusions. These are just any imperfection or that's caused from the misalignment of forms. Again, they're weak. They're not as strong as the surface, so over time they can break off. They're also in another place where you can't get complete coverage of the coating. So if you have a corrosive environment, that is the point of failure. So those would need to be grinded off before the rest of your surface prep and coating would occur. And then form release agents. There are a lot of things added to the forms, to aid in form release, but those can be surface contaminants that would inhibit the adhesion of a coating system on top of that. So any form release agents would need to be removed by pressure washing, water jetting, abrasive blasting, whatever the correct method based on that project would be, but those have to be removed. They would be considered surface contaminants before you apply the coating to that. And then a way that you can actually check for that is the water break test. If you put a drop of water on a piece of concrete, if it beads up and runs off, there's probably a surface contaminant there. We want porous concrete for our coatings to adhere to. And then the other thing is new concrete has a very high pH. As concrete ages and is exposed to the atmosphere, as the carbonic acid or other contaminants, it will lower the pH. And low pH is not our friend. We want a good high pH of 10 to 11 or higher before we apply our coatings. If you have a low pH below 9 or so, you have degrading concrete. It may be a very slow process, but it is degrading. And if you coat over that, the concrete will continue to degrade because you still have low pH. So we recommend a pH test after the surface prep is done to ensure that we've got to fresh high pH concrete. If after the surface prep and there's still a low pH, we need to do more surface prep. We remove more of that contaminated concrete until we get to a good pH that will contribute to a good coating system. Anybody have any questions about any of the surface prep that we have so far? I'm going to turn this over to Brett Huckleberry, and he's going to talk about some of the coating options.
All right, thank you, Mark. And I'll attest to this, Mark will too. We've been with the company a long time, and it starts with surface preparation. It's very important. I'll tell you, every coating manufacturer out there have good products, and I've seen projects not do well because the surface preparation wasn't that great. I've seen projects that had maybe a less specification in it that did great. So, specifications, the surface preparation starts with having a good project. So I'm going to just talk to you a little bit about, we want coating systems to solve your problems. We'll talk a little bit about primers and top coats. We'll have a few minutes for questions. I'm going to touch a little bit just on CMU. I know it's about tilt wall, but I just want to make sure, because a lot of times specifiers, architects get a little confused, what they should specify on tilt walls, sometimes what they should specify as CMU blocks. So it's all about specification tree, what we're looking at, the project, the conditions, and stuff like that. So we're going to look at, obviously, concrete, tilt wall. I'm going to touch a little bit about CMU, just because a lot of times I get a lot of questions about the two. Confusion, what primers, what top coats to use. Appropriate primer. talking about exterior concrete, tilt wall, and their manufacturers do have pH tolerant acrylic primers. That's very important. That allows the concrete to be painted quicker, opposed to hoping for a lot of rain like we've had a few days to lower the pH, or paying money, which your customer might want to do to power wash it to lower the pH. Okay. So block filler is typically for CMU. This is a question I get a lot, when people want to put a block filler in tilt wall concrete. Block filler is very heavy in viscosity. It's meant to fill like pinholes. You're worried about wind-driven rain coming through that wall, so you want a block filler to fill the pinholes of that CMU. Color is white. You can't really tint a block filler. Okay, moving on to the tilt wall primers. Concrete masonry. You might see concrete primer, masonry primer, sealer. Like Mark talked about, a lot of the tilt walls have high pH. You want to lower that. There's some, like I said, primers that will accept pH of 6 to 13, so it allows you to prime that tilt wall quicker, allow that contractor to top coat it. And I always recommend your specifications for that contractor to do a pH test. I know me and Mark were both commercial reps in the field, and everybody's looking around, well, who pays for that? Who does this? And as architects, specifiers, and manufacturers, we're not third-party inspectors, but we will go out there and assist the contractor with a pH test. I always required, when I would do one, I'd like the GC to be present, maybe an architect, not necessarily an owner, but I like to have more than 2 or 3 people out there to witness the pH test. And the contractor should, it's their due diligence responsibility to make sure that pH is low enough before they start top coating and priming that tilt wall. Okay. And masonry primers, they're white, but they can be tinted slightly, add a little color, maybe to blend in with your top coat. So if you had a beige or brown, no two exotic colors like lime green or yellow or red on exterior tilt wall buildings, but you can tint it a little bit to blend in with that top coat. So now you have the paint system, what we call, we got we're looking at primers. Now we're going to look at top coat options, okay, to make that system complete. Typically, tilt walls are done with just exterior latex coatings, 100% acrylic. There are vinyl acrylic coatings that have more fillers, like sand in them. The 100% acrylic exterior coatings give better color and gloss retention over the longevity of that project. Most of our colors in our palette you can use exterior, except for those exotic colors like purple and lime green and yellow. And the good thing about the exterior coatings now, when I was managing stores 3 years ago, you couldn't paint below 55 degrees. That's surface temperature, not air temperature. So now manufacturers have coatings, exterior paint that will go down to 35 degrees. I wouldn't want to be out there painting that cold, but that allows you to extend the painting season on some of these tilt wall projects. Okay, elastomeric coating. That's not applicable to tilt wall. I get asked that a lot. Tilt walls, it's a solid substrate, so you're not worried about wind-driven rain or blowing through that tilt wall. Okay, it's typically made for CMU brick stucco that could penetrate those porous substrates. So now you have your primer systems, your top coat systems. So for tilt wall, make sure you specify a good masonry primer sealer, and then 2 good coats, finished coats of an exterior 100% acrylic paint. Okay. And lastly, I just want to touch about on sheen. I think Mark mentioned it too. Bung holes and patches. You want to use a flat finish, opposed to maybe a satin or eggshell or semi-gloss on tilt walls. I tell people, like, if you go to the car wash and you have your truck or car washed and it's all shiny, new, and you look down the side of it and you go, hey, there's a ding. Where did I get that ding? So if you add sheen to the top coat of a tilt wall, you're going to see all the imperfections, like bung holes, patches. So you want to specify a flat exterior paint, 100% acrylic coating on that. Okay.